take a quick look at a little bit of geometry here. We're not going to get too deep into it, but um, a little bit of geometry just to help you out with some background information. So we're going to look at angles, and there's some different types of angles. There's might want to talk about how to label these. So you might have just just an angle out there. Usually they kind of denote what angle you're looking at with a little curve with a notch or something. They might have a letter, and they may call this angle A. Okay, but there may be other times when you have multiple possible angles. You might have an angle down here, this little angle here, and you might have an angle over here, but then you might also have this big angle here, right? And you might go, okay, well, I want to know which of those angles am I talking about? So in that case, you'll usually have multiple little points labeled. So say this is labeled A, and this point's labeled B, and that's C, and that's D. And so if I'm looking for what is this angle in this area, they would call that angle A, B, C. You can think about it, if you start with point A, you go to point B, and then you go to point C, you can kind of see how that motion kind of defines that little angle in there. So you may have to use 3 variables to describe an angle, or you might just be able to use one if it's just one single angle that's clear what it is. Another notation thing you might run into, you might see something like this with a little M angle A, and what that's saying is measure of angle A. How big is angle A? How many degrees is it? Some quick, a few types of angles. I do that every time. Not angels, angles. Angles. All right. So a few types of angles. We have an acute. This is between 0 degrees and 90 degrees. So that would be type of an acute angle. Like it's small, it's acute, right? Or sharp, acute pain. It's a sharp angle. Then we have a right angle, and this is exactly 90 degrees. And so what you'll see is a lot of times instead of using a curve, they'll just draw a box to indicate that's a 90-degree angle. And then we have obtuse, and that is between 90 degrees and 180 degrees. So something like that would be an obtuse angle. And so if you're ever talking to somebody and they start kind of going off on some direction off to the side, you might say, why are you being obtuse? Why don't you make it clear what you're trying to say? And then we have a straight angle. This is 180 degrees. So it makes a straight line. Let me do that. Straight to the point. Stop deflecting, for the obtuse. And then a rotation. A rotation is 360 degrees. That's when you go all the way around completely from one side to the other. So, if you you might, if you watch Olympics or something, they might talk about like, this person did a 360 dive or something, and they're talking about they're doing a rotation. And then a couple of relationships between angles. If the sum of 2 angles is 90 degrees, they are complementary to one another. So, they may say, okay, what if you have 42 degrees is one of your angles? What's the angle that's complementary to that? Well, it would be 48 degrees, because if you add those together, you get 90. if the sum of two angles is 180 degrees, they are supplementary. Right? So again, for example, if you had 42 degrees and I said, okay, what's the supplementary angle to that? It would be 138 degrees. Because if you add those together, you get 180. So, this can be kind of confusing because these terms are kind of, very similar to one another, complementary, supplementary, and these angle measure 90 and 180. The way I keep these straight is, if you know all the, complementary, supplementary, those words, and 90 and 180, and it's just who goes with who, the way I remember it is I always remember that it is right, 90-degree angle is a right angle, it's always right to complement someone. Always right to complement. So if you remember that, then that would, okay, so all right. They are, you always remember it's right to complement someone, you can remember that pair and then just remember the other pair. Supplementary must go with 180. All right. So that's a brief little thing about angles. Not going to get into any more deeper into angles with that. Another geometry thing we're going to look at is perimeter. So this is the sum of the edges of a figure. Okay. So let's say you had a triangle. Call this side A, B, C. Then the perimeter would be A plus B plus C. You just add the sides up. That's how you calculate it. If you have a rectangle, then you have a length and another length, and you have a width and another width. And so the perimeter is, you take the 2 times the length plus 2 times the width. Because you got 2 lengths and 2 widths. So you multiply, and you take your length, you multiply it by 2 for both of them, take your width, multiply it by 2 for both of them. For a square, well, I can do a square, you have sides, and if it's a square, all the sides are the same length, so the perimeter is 4 times the length of a side. So you take 4 times the length of a side, and that gives you the entire perimeter of the square. And then for a circle is defined by the radius. And so we don't talk about perimeter, what we talk about is circumference. Basically, it's the same thing. It's just, since there aren't multiple sides to add up, we don't call it perimeter. But circumference is 2 times pi times r. So 2 times pi times r. And a lot of times you'll see these, they won't write the dots, they'll just have the 4 touching the s, and touching means multiplying. Touching means multiplying. So, and just a reminder, pi is approximately 3.14. It's actually an irrational number, goes on forever, but we're going to use 3.14 as an approximate value for it. The other type of geometry thing we need to know is area, and this is the space inside of a figure. And so for a triangle, the way you calculate the area is you have to know another value. You need to know what's the height of your triangle, and you know its base. So the height is always measured at a 90-degree angle to the base, whatever is considered the base. And then the area of this, you take 1/2 times the base times the height. And I'll mention in a second why it's 1/2 times base times height. But that's the formula for it. For a rectangle, again, you have lengths and you have widths. And to calculate the area, you can think of like a bunch of little tiles here, And if I wanted to count out how many tiles do I have, how many little squares am I making with my tiles, what I would want to know is how many little boxes do I have across, and how many little boxes do I have down. And so the area is length. That tells you how many boxes you have this way, and then times width, how many boxes you have that way. You multiply those together and tell you how many little boxes you would have inside your thing. Now, let me go back to the triangle. Why is triangle 1/2 base times height? Well, if you were to take this height and just kind of push it off at the end here, and push it over here, what we would see is this is actually half of a rectangle. It's half of a rectangle. You know, this little triangular area is half of that triangular area, and that triangular area is, matches with that triangle. So this is half of that rectangle. So if you take base times height, that is half of a rectangle of that length and width. That's why it has that half there. And then for square, so you got a side, you got a side. So the area, you can say this same as base times height, but I don't want to say S and S, A and then S and S, it might look like a bad word or something. So instead what I'm going to do is I'm going to say, well, S times S is just S to the second power, or another way of saying that is S squared. The reason why we call it squared is because it refers to a square. That's why that when you raise something to the second power, it's called squared, because it's S squared when you're talking about a square. For a circle, again, circles are based on the radius. The area is pi r squared. Pi times r squared. Do not confuse these formulas for your perimeter formulas. So you use the same letters, but except for the triangle has an additional value of a height. You don't use the height for perimeter, but you do need to know it for the area. So there's different formulas. You should know perimeter and area for these four figures: triangles, rectangles, squares, circles, by heart. They're kind of like the standard, most basic geometry figures. So let's go ahead and we'll do a real quick example problem here. Find the area and perimeter of this triangle. Okay, and they're going to give us a triangle here. They'll have to give us the height because they want us to get the area also. So let's say this side is 5, that side's 3, this is 7, and this has a height of 2. Okay, and I don't know if that works, but we'll pretend it does. Okay, so to find the area, that's 1/2 times base times height. So it's going to be 1/2. The base is 7, and we'll say these are centimeters. Okay, give it a unit here. Centimeters. So 7 centimeters times, and the height is 2 centimeters. So 1/2 times 7 times 2, well, 2 times 1/2 is 1 times 7. This is going to be 7, and then centimeters times centimeters is centimeters squared. Area is always in square units, because what you're really doing is you're making a bunch of little squares here. So it's always square units here. Okay. Perimeter. Well, perimeter we just said was A plus B plus C. So that's just adding the outside edges. So 5 plus 7 plus 3. 5 plus 7 is 10. Plus 5 is, and okay, there's centimeters, centimeters, centimeters. I should use the units. So 7 centimeters plus 3 centimeters is 10 centimeters plus 5 is 15 centimeters. I'm just counting up how many little centimeters is it, along this thing here. So that's all I'm doing here. Just counting up how far is it around the figure. So that's how you calculate perimeter and area.